So continue with part B and part C. So part B is asked you to calculate the pH of KH2PO4. So KH2PO4, when it's in water, it will be separate into potassium ion and H2PO4 minus. So this is the actual molecule that you need to calculate the pH. And similarly to part C, K2HPO4, so when it's in water, it's also separated to potassium ion and HPO4, 2 minus. So this is the molecule that you need to calculate the pH from. You notice that H2PO4 and HPO4, 2 minus here is the intermediate species in the polyprotic protonation. So in order to calculate the pH of these intermediate species, there is only one equations which will consider the use of two different pKa that cover the molecules. So for example, in part B, the equation of pH will be the average of two pKa, the pKa1, pKa2 divided by 2. So for part B, KH2PO4 is actually this molecule. So the pKa that you need to use in the equations will be either both 2.12 and 7.21 here. So the pH of KH2PO4 will be equal 2.12 plus 7.21 divided by 2. And similarly, for part C, the pH of K2HPO4 will be using two different pKa, either 7.21 plus 12.32 divided by 2. So this is how you calculate the pH of the intermediate species. So one thing to keep in mind is that when you are given this kind of molecule, KH2PO4 is actually H2PO4, right? And K2HPO4 is actually referred to HPO4 2 minus. So that is the answer for this part of questions. The reason why we use the average of 2 pKa is because these intermediate species can either go forward to protonate more or go backwards to receive proton from water. So the two different pKa need to be used to calculate the pH of the intermediate species.